9.5, section 9.5. What's the title of that, kids? Sine and cosine. Now, in your calculator, kids, in your calculator, do you have a button that says this right here? And I say every time I eat candy, right here. Right? Yeah. And then, if you see this in your calculator, this stands for sine. And then what's the other one we're going to have, guys? You'll see it in your calculator as what? COS. Okay, now Mrs. Hill was here on Friday. Or I'm sorry, Thursday, wasn't she? She gave you a word to remember that. You remember it? So you guys see this orange poster up here? Has them all right up here. So if you ever need a quick place to go, it'll tell you right here. Okay? You guys cool with that? It's kind of faded. This poster's been with me as long as I've been teaching. It's 20 years old. So, what's that? All right. Are you guys finding the sine and cosine buttons in your calculator? That's your first job. I want you to make sure you can find a sine button and a cosine button. Are you there? Yes. Do this for me. Type in sine of 90. Now make sure we have the right mode. Everybody type in sine of 90. What's it kick out? 1. It should kick out 1. Okay. Type in cosine of 90, and it should kick out 0. Okay. So everybody in the right mode? Everybody comfortable with their calculators in terms of sine and cosine buttons? All right, let's rock and roll, guys. I need a volunteer to read my essential question for me today. Who wants to do that? Thanks, Sonny.
How is a right triangle used to find the sine and cosine of an acute angle? Is there an acute?
Acute? Acute.
I say acute. Acute. Wait, did I say acute or did I say acute? Why did I do that?
I don't know.
Is there a unique right triangle?
Probably because it's Monday morning math, okay? Is there a unique right triangle that must be used? Well, guys, really, this is going to be very similar to what we did in the last section. So if the tangent function was fairly easy for you, this is kind of the same setup. We're just going to have some different definitions in terms of what's given to let us solve for sides. If you recall in the last section, which side didn't we care about when we were solving?
Hypotenuse.
Didn't care about the hypotenuse. Guess what we want to worry about today?
Hypotenuse.
Okay, the sine and the cosine are actually going to be the two trig functions that involve the hypotenuse today. So we're going to be using hypotenuse for this stuff. So we want to know, is there a unique right triangle that must be used? So in order to answer our question up here, first goal, use the sine and cosine ratios. I'll show you how to do that. We're also going to find the sine and cosine of angle measures in special right triangles. We're going to look at some real-life problems involving sine and cosine ratios. And then we're going to use what's known as a trigonometric identity. I don't know if I'm going to go into the identity as much as I am a drawing to help you understand what's going on here. But guys, these are the very basics of trigonometry. And I hope that every single one of you in here is enrolled in trigonometry at some point next year. Okay? I strongly encourage you to take trigonometry because in terms of your ACT test, you're putting yourself ahead of the game. All right? So if you can find time next year, how many have got their schedules already completed?
I mean, I turned it in, but she doesn't really like me, so she's not really what I want.
Oh, Grace.
What?
We all like you.
That's a lie.
I like you.
Yeah, but that's not real.
Well, but I'm the only one that matters, right?
Yeah.
There you go. All right. So my point being, take trig next year, and we're kind of starting the basic foundation of it. Okay. All right. Let's get rolling on the vocabulary so we can handle this today. Sine function. Somebody want to read that for me?
What?
Well, we want to read this.
Ratio of a line opposite of an acute angle over the hypotenuse.
Okay. So basically, this is going to be the opposite. It's going to be the opposite leg, which I'll abbreviate OPP, over the hypotenuse. So if I had a right triangle like so, kids, in this, if I had a right triangle like this, and I called this 5, 12, and 13, and I said this is angle A right here, kids, what would the sine of angle A equal in that?
5 over 13.
Sine of angle A would equal?
5 over 13.
Sine of angle A would equal 5 over 13 because, again, by definition for sine, it's the opposite leg over the hypotenuse. So what's opposite of A, kids?
5.
And what's a hypotenuse length?
13.
13. Happy with that? What if there was an angle B up here? what would the sine of angle B equal?
12.
12 over 13. So sine is what over what, kids? So what do you want to say about cosine? What is that?
Hypotenuse over.
Adjacent.
It's the adjacent leg over the what?
I was looking at
Hypotenuse.
Which I'll abbreviate ADJ over HYP. I'll give you the same darn triangle up here again. And suppose I call this angle A with lengths 5, 12, and 13. If I wanted to know the sine ratio of angle A again, kids, in my diagram, what leg is adjacent to angle A? 12. What's my hypotenuse? So how about the cosine ratio for that? 12 over 13. You guys are catching on to this really well. I'm impressed. Okay.
easier than the last one.
A little bit. I mean, I honestly think I think they're all kind of the same. But if I had to say, well, one's more difficult than another, I might say tangent sometimes is the one that's more difficult.
Because like you know like the hypotenuse right away. Like,
Yeah. Yep. Tangent is kind of easy to take the two numbers and do well with them sometimes. I saw that a lot in the last section, but I think we'll be okay. Now, guys, we kind of touched on this in the last section, but again, we have angle of elevation. If I have a horizontal line right here, from that horizontal, if I look up, what kind of angle is that?
Elevation.
If I look down from that horizontal, that's an angle of what? So this might be my horizontal right here. This might be my horizontal. And if there's an angle below a horizontal line, this angle right here is called my what? Angle of what? Okay, so I just write AOD in there. Is that all right with you guys? Can you handle that? Okay, so I think you guys knew that already. Okay, as far as vocab goes, do you feel comfortable using that terminology moving forward on the examples we're about to look at?
Yes.
Questions on the first page, kiddos? Give me a thumbs up if you're all right now. Let's roll. Example number 1, page 2. So, it says finding the sine and cosine ratios. It says find the sine of A, sine of B, cosine of A, cosine of B. Write each answer first as a what?
Decimal.
Fraction, then as a what?
4 places. Oh.
Decimal to what?
4 places.
I'm going to kind of divide this part up over here like so. All right, so I want you to find the sine of A. I want you to find the sine of B. I want you to find the cosine of A. And I want you to find the cosine of B. So you guys go ahead and take a moment and do that as a fraction, not necessarily simplified. I don't know what big ideas is going to do. Hey, when you have those 4 answers, check with the neighbor around you. If you disagree, talk about why you disagree, all right?
Hey Carson.
Yeah, bud.
So when we're trying to find the decimal, do we like press the sine and cosine buttons?
Don't have to do anything here. No, nothing here. You're just going to do one side over the other and then divide that ratio out. So for instance, what do you have for sine of A, kids?
15 over 39.
15 over 39. Now some of you might choose to reduce that fraction. That's fine. But your decimal is going to be whatever 15 divided by 39 is. Okay? Hey, Liam. How are you today?
Doing all right.
Good. Did you have a good weekend?
Wish it was longer.
Me too. I think everybody does. Hey, be careful. Don't trip over that, guys. Hey, whose Chromebook is that? Whose Chromebook is up front charging right now?
That is mine.
Okay, I'm gonna move that down to the floor so no one trips on that, alright?
I don't know. I wasn't thinking about it, alright?
It's okay, Cam.
Well, it's not. No.
It's just like a hurdle. If there's any track girls that came through, I'd be like, hurdle it, right?
There's one girl that came through.
Thanks, Cam.
I'm seeing a pattern.
Same.
Okay, who needs more time here?
Grace does.
Okay, give you about 31.4 seconds.
After you said that, I'm like, consider me done. That's literally a smartphone. That's what it's like. It's like a giant. Yeah. It's dead. Rocket's dead, same thing. Unless something dies, then rocket.
All right, let's talk. What's the sine of angle A ratio-wise, guys? 15 over 39. Did you guys divide that out?
Yeah.
What'd you get?
0.3846.
3846. Okay, you guys agree, sine of angle A, you're standing right here. What's opposite of A? Over the hypotenuse? How many had sine of A correct? Did anybody choose to call that 5 over 13, reducing that? You could have, and I'm okay with that. If you didn't, then totally up to you. How about sine of B, kids? B is down here, kind of got cut off. 36 over 36 over 39, which is equal to what? What's the decimal equivalency for that?
Years ago, if I said Dave had
0.4.
but now you think
9231.
923.
Yeah, Sunny's bad at speaking today. It's fine.
Sonny, I'm deaf in my left ear.
I pressed for someone.
Why do you guys think I put my desk this way and you guys that way?
Ha ha.
Oh, I'm kidding.
Ha, ha.
I'm kidding, guys. Come on, smile a little bit. All right, what'd you get for cosine of A, kids? You're back at A. How about cosine of A?
36 over 39.
I'm going to guess that 36 over 39 is about 0.9231, Sonny.
No.
Guys, what do you notice about the cosine of A and the sine of B?
They're the same.
So if you know the sine of A, you probably know the cosine of, what is the cosine of B down here? What is it, Jason? 15 over, how about a decimal equivalency for that? 46? Hey, listen to what I say. If you know the sine of A, you also know what?
Cosine of B.
If you know the sine of B, you know the,
Cosine of A.
does that make sense to you?
Yeah.
Want you to make that connection, okay? All right, so let's make sure we all agree on example 2. This is kind of a calculator problem. By the way, backing up, just give me a show of hands or a thumbs up or whatever. Nod, whatever you want to do, but how many had all 4 of those? We okay with that? Okay, any questions about that at all?
Nope.
All right, minions, let's go sine of 56 degrees. It says write the sine of 56 degrees in terms of what? Okay, this is actually a pretty important problem, and I want to make sure you understand this. So here's how this is going to work today, kids. I want you to draw a triangle for me, a right triangle nonetheless. Here's what this will look like. Okay, first of all, what type of triangle do I have here, kids?
Right triangle.
Okay. And in this right triangle, I want you to put a 56-degree angle up here, all right? Okay. So here's the situation. It says write the sine of 56 in terms of what? Okay. Well, here's the deal. The sine of 56 would be this length A over what? But here's the deal. Wouldn't the sine of 56 degrees equal A over C, kids? Let's see, if I'm at 56 degrees, then the opposite leg is what? And the hypotenuse is? Okay, let's talk about this. This is write the sine in terms of cosine. We want the values to be exactly the same. Now, kids, what's your definition of cosine again? If I was using just these two values right here, A and C right here, where would the adjacent angle lie? Wouldn't it lie right down here? Right? Okay. Now I'm going to make this very simple for you in a second, but could you find this angle down here?
34.
It's 34 degrees, right? Wouldn't the cosine of 34 degrees also equal A over C? So the sine of 56 is going to be the same as the cosine of 34 degrees. Let me make this very simple on you. If I say, hey, what's the sine of 60? How much more is 60 to make 90? So the sine of 60 is going to be exactly the same as the cosine of 30. So here's one for you. Cosine of 40 is the same as sine of 50. Sine of 10 degrees is the same as cosine of 80. All right, ready for another one?
Yeah.
Sine of 20 degrees, cosine 70. Okay? If you know the first angle and you want to change from sine to cosine or vice versa, you take the angle you know and subtract it from what? Okay, so can I write a rule up here? Here's a rule right here. This will be pretty easy. Actually, there'll be two parts to this. Let's say the sine of A, some angle A right here. This is going to equal the cosine of 90 minus A. Okay? Or if you start with a cosine, maybe a cosine of angle B. What do you think cosine of B will equal in terms of sine? 90 minus what? $90 minus what? Ah. All right, so I think you get that. So again, if I say something like cosine of 85 degrees, that's the same as a sine of 5 degrees. Okay, you've got that. Okay. All right, any questions about that? What's that? All right, this is where things get pretty interesting. I like this part right here. Okay.
WSB.
Where are you at?
The second rule.
Cosine.
Rule.
COS, cosine of B equals sine of 90 minus B.
Oh, that looks like a W.
I'm sorry.
He's being picky today. It's fine.
That's all right.
I am too.
He's paying attention to detail. I'll give him that. I like that. Is that better?
Yes.
Okay. All right, next one says find the values of what and what, kids?
X and Y.
Okay, I'm going to divide this into two halves like this. I think I can pull it off this way. Let me blow this up a bit. Let's find x first. And I'll put y over here, kind of like a T-chart. You ready? All right, here we go. Guys, first of all, what's your reference angle on this right triangle?
35.
35 degrees. So we are where? That's where we are, right? I want to find x. What distance do you know here? You know the hypotenuse. So once the hypotenuse becomes part of solving a trig equation or a trig function or some kind of problem that models trig equations, if the hypotenuse is involved, we're probably going sine and cosine. All right? Let's look at x here, kids. How is x related to my reference angle?
It's
This is the opposite leg. This would be the adjacent leg. So I'm going to label those like so. All right, here we go. To solve for x, if x is an opposite leg and I know the hypotenuse up here, am I getting sine function or cosine function for solving for x? We're using the opposite leg. X is the opposite leg, so I have to use
Sine.
Sine. So here's what we're going to go. We're going to say the sine of, how many degrees, kids? 35 degrees equals, by definition, opposite leg over hypotenuse would be opposite leg x over. All right, so now what do you think we're going to do, kids?
Sine of 35
Okay. Yep, I want a decimal equivalency for sine of 35 degrees, and I want that decimal equivalency to how many places, kiddos?
4.
Yeah, so what's that punch out to be?
30.31.
Point.
I got 30.3.
Okay, you're ahead of me. Just do sine of 35 for me first. I like your answer, don't get me wrong.
0.5736.
Remember what I said, anytime you do any of these trig functions in your calculator when you're solving for an unknown side in a triangle, always, always, always put that decimal over
1.
1. Okay? This is still going to be equal to what ratio now, kids? X over. Okay, now, what you've done essentially is set up a proportion, so we're going to cross multiply and divide. By the way, when I solve for x and y, how should my answers be relative to 53? Longer, shorter?
Shorter.
Better be shorter, because which side is always the longest? Exactly.
Oh wait, is it 5,736 or is it the decimal?
That's 0.5736. I made a really big decimal point.
Alright. Oh, I thought that was
I'm sorry.
No, you're fine, you're fine.
So cross multiply that. Tell me what you come up with for x. Let's go nearest tenth.
30.4.
And Sonny, I'm going to come back to you. Is that what you had? Okay. I want you guys on your own to try and set up an equation for y, and then work your way through your equation, see what you come up with, okay?
Just take the sine. You want us to solve the entire thing?
Yeah, go ahead and figure out what y is. And again, same game. Once you guys have an answer, check with someone around you, all right?
You want us to do tenths? Oh, yeah.
Yeah, I'd say your final answer when you're looking for a decimal equivalency, go 4 places because that gets me a more accurate estimate on the length.
4 places?
Well, 4 places up here when you punch the trig function, but in the final answer, just go nearest tenth.
Do we have to do that step, or can we just go straight to the answer?
Well, you could. I'm curious as to how you guys solve for y.
Cosine.
Cosine 35.
Cosine of?
35. And then I took that.
Sonny, can I back up on what you said?
Yeah.
Okay. Grace, hold your thought right there for me. I would still probably set this up like so because I don't want you to lose sight of the fact that if you do that, sometimes the unknown you're looking for is a hypotenuse. So it's not always going to be just take that number and then multiply. You might have to do some division. Make sense? I mean, I'm not telling you no. I'm not telling you no. I'm just saying be careful if you do, okay? All right? All right, Grace, where were you at again? What over what?
9 equals y over 35. And then you're going to take
35 or 53?
53. I'm an idiot.
Nope, you're all right. They're trying to trick us intentionally. I need to recalibrate, guys. Give me a second. How many agree with the equation there first? Yeah.
Do you know if Jenny's bringing the junior high girls over on Wednesday?
I don't, but I'm sure that she would be okay with it if you wanted to email her or
I just don't want this thing to last too long.
what's that?
I want to make sure it's not, last too long.
Yeah, sure. We don't need to have a ton of people, I don't think. So, check with her and see. But I wouldn't necessarily think so. You just emailed Schmidt, didn't you?
Well, last week.
Okay. Yeah, I think if we have just one class or whatever, it'll be okay. You know, I don't think we need a lot.
Maybe just keep the junior, maybe I'll do the junior high, you guys can have practice.
Sounds good. All right, very good. Okay, where was I at here? What's cosine 53? Oops, I was going to recalibrate, wasn't I?
35. Have you never seen this before?
All right, go ahead. What was the cosine of 35, 4 places?
0.8192.
Put that over.
1.
Where you guys at with that?
43.43.4.
43.4. How many agreed? Okay. Gavin, question, buddy? Okay, do you have your calculator handy, kiddo? Punch in cosine of 35. Make sure that agrees. I want to make sure your calculator's in the right mode so that works for you. Did I give you what you need there? Okay, that's where that came from, kiddo. All right, so we're going to cross multiply and divide nearest tenth again. I'm sorry, I didn't catch that there.
43.4.
Yeah, show of hands, but how many were right around that 43.4 number? Okay. How many are like, yeah, I'm pretty confident with this right now. And even if I throw back tangent, okay, you've got to be able to differentiate between, okay, is this set up as a sine function, a cosine function, or a, from last section, tangent function? Okay, so make sure you're able to differentiate that.
Look at the chart.
Yeah, like the tangent would be you don't know anything about the hypotenuse. Make sense?
Yeah.
Okay.
Wait, tangent, you're trying to find them?
Yeah. Hey, by the way, could I have used tangent? Could have. I could have said the tangent of 35 would have equaled, did we know the opposite leg now? 30.4 over what? Could have done that too. Okay. All right. Let's move ahead here. I want to make sure, do you guys have everything you need from that example? Okay. All right, let's move. Example number 3. I like this example right here. It says, which a ratio are equal to root 2 over 2? Select all that apply. Well, first of all, kids, this is a special triangle. What kind of triangle is this?
Right triangle.
It is a right triangle, but we've talked about this one right here as a
45,
45, 45, 90. So here's what I'm going to tell you. Let's see what we remember. All right. Guys, how am I going to work back from the hypotenuse of 9 to get back to a leg if it's 45, 45, 90? What do I have to divide by?
Divided by root 2.
Divide by root 2, right? So this becomes 9 divided by root 2, doesn't it, kids? Which is really equal to, help me out here. Oh, this is going to get really ugly, and that's not fun. Give me 9 root 2 over what? If I multiply the top and the bottom to rationalize this, wouldn't this be 9 times the square root of 2 up top? All over what? Square root of 4, which would have been what? I'm going to highlight this right here. This is the side length right here, which means this length over here is what?
Yeah.
So I'm confused how this just happened. Yeah.
What do you mean?
Like, I'm confused what we did.
Well, isn't the hypotenuse the square root of 2 times longer than the leg right here? Like if this was 4, this would have been 4 root 2. So to work backwards, we had to divide by the square root of 2. This is all from special right triangles, 45, 45, 90, and 30, 60, 90. To go from 9 to this side, I'd have to take 9 and divide it by what, kids? But do I want the square root of 2 in the denominator? Okay, besides dividing by 0 in math, this is maybe the second worst thing that can ever happen in math right here. So I have to rationalize this. I have to multiply both the top and the bottom by root 2. So I multiply 9 times the square root of 2 up top. If I do root 2 times itself, it's the square root of 4, which is what value? 2. And since a 45, 45, 90 is half of a square, this side down here will equal that side. So there's 2 legs in these. 9 root 2 over what, kids? All right. So the question becomes, kids, apply the ones that are simply going to be root 2 over 2. And I'm going to make this very simple for you. The sine of angle A. Let's just do sine of angle A. Sine of angle A would be, I'm right here. What's the opposite leg, kids? 9 root 2 over 2. And now we're going to divide that by what? 9. So this really becomes 9 root 2 over 2. But you're really dividing by 9. And when I divide by 9, it's like throwing it right down here. Guys, what do the 9s really do to each other here? And you're left with what over what? So does the sine of A work? Absolutely. Take a look at the cosine of A. Wouldn't the cosine of A be 9 root 2 over 2 divided by what again? What are you dividing by here, kids?
No. Big no. Big no.
Isn't that going to be exactly the same thing again? Okay, cosine of A is going to work. It's going to be the same thing, which is root 2 over 2 again. Now, the one I'm concerned about, tangent of A. You're taking the tangent of A, opposite leg over adjacent leg. Aren't you taking one thing and dividing by the exact same thing? So what's 6 divided by 6? So what's one thing divided by the same thing going to equal?
1.
So the tangent of A in this right here would not work. It would be 1. Let me look at the sine of B. But guys, the sine of B is going to be exactly the same as cosine of what? Remember that? Is that going to work? Cosine of B would be the same as the sine of A. Tangent of B will be the same as the tangent of A here. So which ones are going to work as root 2 over root 2?
Hey Carson, I'm kind of confused. Am I kind of like really?
So where are you at?
Cosine of A.
Cosine of A?
Sine of A, cosine of A were opposites.
Say that one more time.
Cosine.
Okay, so you said you thought the sine of A was opposite what?
No, I thought it's the same. Okay, why did you write the same for cosine A and sine A?
Well, because it's going to be the same numbers, that's what I meant right here. Okay, so the cosine of A would have been this 9 root 2 over 2, which is what I used in the sine, right? Aren't these values on the legs exactly the same?
Yeah.
That's what I meant by saying, okay? So, yeah, I don't disagree with you what you're saying. The sine of A would be the same as cosine of B, right? And then the sine of B would equal the cosine of A, which we both knew was root 2 over root 2 there. Okay, I just wrote same here because it was going to be the same as this division problem right up here.
So how'd you get that second 9? The one on the bottom.
Because I had to divide by the hypotenuse, and when you divide by the hypotenuse, it's like putting it down here. Because your whole part in black right here was the opposite leg,
Yeah.
divided by the hypotenuse of 9. What did the 9s do to each other? And you were left with root 2 over 2. So guys, the thing I'm getting you to understand here is this. Right here, all these angles A and B were how many degrees right here, kids? How many degrees were they? Okay, so this is what I want you to understand. Okay, you ever see the sine of 45 degrees? That's the same as root 2 over 2. You ever see the cosine of 45 degrees? That's equal to root 2 over what? 2. Do this for me. Who has a calculator? Take the square root of 2 and divide it by 2. Tell me it's 0.7071. Is it 0.7071? Yep. Is it 0.7071? Square root of 2. Enter. And then divide by 2.
Yeah.
Okay, so 0.7071. All right. Now do this. Punch in sine of 45.
Yeah.
Punch in cosine of 45. Same thing, right? Okay. All right. So I'm not gonna go. Well, why not?
Are the special right triangles going to be on the test?
Oh yeah. Yep. All you need to know out of this mess right here, the sine and cosine of how many degrees is simply going to be what over what?
Always?
Always. Okay? Because think about it. Isn't 45 half of 90? Remember when I said the sine of 60 is the same as cosine of 30? Well, we were subtracting 60 from 90.
Oh, okay, yeah.
Okay? All right. So let's try another one here. Finding the sine and cosine of what here, kids? Okay, ones that apply. No problem. If this is 60 up here, kids, what's this angle have to be in example 5? Okay. So this would be 30 right here at P, wouldn't it? All right, so they want to find all that apply. It says find up here which ratios are equal to what, kids? 3 over what? Okay, let's look at the sine of M. Sine of M. What's the definition of sine again, kids?
Opposite of
So what's opposite of M? Over. Okay, how about the sine of P?
wherever.
Okay, make sure you're at P. Sine of P. So it would be opposite of
Okay.
1 over 2. Okay. Let's see. Let's go cosine of M, kids. So I'm at M again. Think about it, guys. Wouldn't the sine of P be the same thing as cosine of M? And if I'm at M, what's the adjacent leg? And what's the hypotenuse? So 1/2 again. How about cosine P? So the question becomes, what was it again? Okay, which ones worked? Well, the first one that worked was sine of what? And if the sine of M works, that means the cosine of the other acute angle must work, which was P. That was a lot easier. Okay?
Yeah.
I think the thing that threw you is the 9 in there. All right. Anybody need more time that page? Last page here, page 6. Let's roll. Okay, I like this one. It says you're skiing down a what, kids? A hill with an altitude of how much? 800 feet. The angle of depression is 15 degrees. Find the distance x you ski down the hill to the what? So you're going to start here and go to here, right? All agree? What's the altitude that you're starting from? How high up are you? Now again, kids, I want you to understand this. This is kind of tough for kids. The angle of depression comes from a horizontal. And where did we start at?
The top ones.
You started right up here. We are starting up here. Okay? Now, you need to imagine right here that there's a line. You need to imagine right up here that there is a line like so. This is like your horizontal right here. This is your... Okay, what's the angle of depression between the horizontal and the slope you're skiing down? 15. So this angle is 15 degrees, isn't it? All agreed? So the question becomes, kids, find the distance x that you ski down the hill to the nearest foot. You're looking for a hypotenuse here. Now, kids, is that 15 degrees horizontally in the triangle or outside of the triangle? So we probably need to know an angle inside the triangle. So what's that force this angle to have to be right inside here? Okay. Something like this. Always draw what? Always draw your horizontal and know if you're talking about elevation or depression. Depression typically falls outside of examples like this. And that's okay. So here we go, kids. I want to solve for x. I have a reference angle inside the triangle of 75 degrees. How do you want to set this up? Here, 800x.
We're starting at 75, right?
Yep, and the thing that's tricky about this, kids, now, we're throwing two trig functions. You've got to choose the right one. Huh?
It's going to be tangent, isn't it?
How is this related to 75 degrees right here? How's the 800? It's an adjacent leg. What is x? So which of my three functions involves the adjacent leg and the hypotenuse? The cosine, right? So Leighton, help me set this up. We're going to go cosine of how many degrees? Cosine of 75. That's going to equal my adjacent leg of over x. Okay. Talk to me, kids. Cosine of 75 to 4 places, please.
Why would it be cosine?
Well, you tell me again, because it's... This is an adjacent leg to 75. Okay. 2580. 8. What's the last one?
8.
Like so, Sonny. I'll put that over what, kids? My answer going to be longer than 800 or shorter than 800? Better be longer because we're really looking for the... Yep. So 800 times 1 divided 0.2588. How many feet are we skiing? I'm sorry. Whoa. Listen up, guys. How much? 3,091 point. Okay, real quickly, I want to get through that last example. But again, kids, it makes sense that that answer is more than 800 because we were looking for which value in the triangle. And that's always the... Exactly.
So how did you get the 3,091?
800 times 1 divided 0.2588.
Oh, okay.
All right, last one here quickly. Guys, I sent out your online assignment for 9.5 already, so take a look at that. All right, you're going to start seeing symbols that look like this. This is called theta. Okay? I have a right triangle, and I have an angle theta that's acute. It says, given that what, kids? Sine of theta equals... Okay, let's talk about sine again. Sine is what over what?
Or
Opposite over. Okay. So kids, when they're saying this right here, they're kind of like saying, oh, the sine of theta is 1/3. It's like saying the opposite leg length is up top 1. The hypotenuse is 3. Okay, so I'm going to put a 1 at the opposite leg of theta, and I'm going to put a 3 at the hypotenuse.
Why did they have it labeled that?
Theta is just like a variable x, okay? It's just a Greek letter. It's a Greek letter that they use. Guys, could I use Pythagorean Theorem to find this last side?
Yeah.
What's 3 squared?
9.
What's 1 squared?
1.
What's 9 minus 1?
8.
So this is really the square root of 8. Now, guys, I'm going to leave it as the square root of 8, but I could call this 2 root 2 if I wanted to. Because think about it. Isn't 8 4 times 2? Isn't 8... What's the square root of 4? 2. That's this front 2, and then this is the root 2. So once I know that, kids, could I find the cosine now? Let's use the square root of 8 right here, all right? Let's use square root of 8. Cosine of theta now. Or adjacent leg over hypotenuse. What's the adjacent leg?
Root 8.
Root 8 over what? Yep. Adjacent leg root 8 over hypotenuse of what?
Yeah.
Okay, how about the tangent? How is tangent defined again?
Opposite over.
What's the opposite leg? 1 over root 8. Probably going to leave my answer like that or do something to it.
1 times root 8 over 8.
1 times root 8 over 8. Okay, we might call this root 8 over 8. I'll talk more about simplifying that there tomorrow. Okay? So don't forget the online 9.4 that you guys have out. I'd like to have by 6 o'clock for today. 9.5, I sent that out. Not due until